Today, we start our journey into trigonometry. So we're shifting gears a little. We've been dealing with logarithms a lot. And now we'll go into trigonometry and we'll sort of start from the ground up. And this is something you've had before, but we'll take maybe a different look at it. We'll look at it in the context of calculus and precalculus. And we want to make, so you'll be getting new terms you've heard before, but we'll deal with them again. And they'll start to build on each other. So we're starting again kind of from scratch. And we're starting today just talking about angles. I like to draw a little parallel. We're going to be talking about two ways to measure angles. We're going to be talking about degrees and radians. I like to draw a parallel between logs. You know your regular log base 10, your common logs, and the natural log. You're probably used to, and log base 10 is very intuitive, and you know these things sort of offhand. You know, log base 10 of 2 is going to be 100. These are very easy to calculate, and sort of it's a everyday working kind of logarithm. Natural log, however, becomes very important in calculus and dealing with the exponential e to the x. Natural logs become vital in calculus because they work out very nicely and they have very nice properties. Similar, much the same way with the degrees and radians. Degrees are something you're very used to. So you could measure this angle in degrees, and you know that a circle is 360 degrees. Degrees are very intuitive. We talk about doing a 180 on a subject. And some people like to say 360, or we know what 90 degrees is. And there's a few important angles we know. So we're very used to degrees, but degrees don't work as well in calculus. They don't have as nice property as radians. So eventually we're going to be switching all into radians. And just like we are intuitively familiar with logs, we have to go to natural logs to make things nice in calculus. In calculus we have to go to radians to make things nice. So we're going to be talking a little bit today about making this switch. First of all, angles. We're going to be dealing with triangles a lot. You know that angles show up on any point here, any of these points. And they're sort of measured with this arc. And we're going to be using all kinds of letters for these, like A, B, and C. We're also going to be using 3 Greek letters, maybe 4. One we're going to use most is theta. If you're German, maybe say theta. Some African students say theta too. So theta is a Greek letter going to be used a lot. The other one is alpha and beta. So Greek letters, wonderful, fun things we're going to be using. Usually we use these in angles. We use theta a lot. And the fourth one is phi. P-H-I. Phi. If you know like sorority kind of things, they often say this is phi. Like phi beta. But it's really pronounced phi. Theta and phi often go together. Alpha and beta go together. So these are some Greek letters that you will be running into this year. Alright, so let's talk about the difference between degrees and radians. Basically, they're just another way to measure angles. If there are 360 degrees in a circle, and a right triangle is 90 degrees, we use a little right triangle symbol to measure that. Then with radians, it's simply, instead of 360, it's 2 pi. Which seems kind of strange. 2 pi is like 6.28, I think. 2 pi radians. Alright, so going all the way around here is 2 pi. This means going this far is going to be pi. Just as going this far is half of 360. So this is pi radians is 180. And halfway is going to be half of pi, or pi over 2. You can see, go by half pi's, this is going to be 3 pi over 2. We often leave the pi in, but we could write them out. The problem is pi is can't be written out in a simple form. So we often leave the pi's in. And this is really the big difference. So we're going to start out learning to convert between these two things pretty easily. And one of the things I want to show you is something which will become very useful if you go into chemistry and things. You probably already had it in chemistry, I think. And it's called, I think this may not be universal calling it, but it's the factor label method of converting units. Chemists have to convert units a lot. You convert moles into grams and things. Actually, it's more, not really converting units often, but we're going to use the factor label method, which says 360 degrees equals 2 pi radians. Radians is often said to be unitless. It's sort of a gray area. For degrees, you should put the little circle on there to mean degrees. You can write out degrees if you're if you have to type it out. And the bottom here is in radians. So the factor label method says, say you had 23 degrees and you wanted to change that into radians. The factor label method says this thing equals 1. 360 degrees is the same thing as 2 pi radians. So multiplying, so if these are the same thing, this is really 1. So you can multiply any number by 1 and not change it. So if we wanted to get rid of the degrees here and have radians, we would write this factor label and we put the degrees on the bottom so they would cancel out. I'm going to write in the word radians, but we often leave it out. Alright, so we want to change 23 degrees into radians, and for that we multiply it by this factor. So this will cancel out the degrees, and we'll be left with radians. So 23 degrees is 2 pi times 23 over 360 radians. Should we get a number for that? Sure, why not? Let's see if I have a calculator here quickly. It's called calculator. Isn't that cute? 2 times pi. I'm just going to use 3.14 here because I'm not sure where the pi is. 2 pi is that. That's also how many radians are in a circle. So it's like almost a sixth. So actually it comes out to be like 60 degrees. So this is like 1 radian in. But we rarely use radians straight. We use the pi form of them. Let me get my calculator back. So that's 2 pi times 23 equals 144 divided by 360. So it's going to be 0.401 radians. Alright, and that's what 23 degrees is. We're just converting units here. We could write that as a pi value, but we won't. Won't make things more difficult. So we can go the other way. Say we had, well, just for fun, we'll pick, I keep forgetting I have this, pi over 2 radians. So we want to convert that to degrees. Well, we can use our factor label again. I'm going to write it down here. Pi over 2 radians. I'll shorten it as rad. So we want the radians to cancel out. So we want to leave it sort of in this form here. You can see this is this factor label upside down. This equals 1. This also equals 1 when you flip it over. So we'll multiply that into pi radians. Over 360 degrees. This way the radians will cancel out. And we'll be left with degrees. I'll write it over here, 360 times pi over 2 times 2 pi, or 4 pi. Now we can plug this into a calculator, calculate it out. But we can also say, well, these pi's also cancel out. To make it a little simpler, it's 360 over 4. Where it's 360, half of 360 is not 180. Half of that is 90, so this equals 90 degrees. 90 degrees and 2 pi radians are the same. Alright? So this is how you convert back and forth. Pretty simple stuff, but it's going to become vital that you become fairly adept at this. And we're going to be talking about 90 degrees sometimes, and we're going to talk about pi over 2 radians sometimes, and this is a way, using this factor label, you can switch back and forth easily between the two.